For Section 2.4, we're going to look at applications. In other words, we're going to be looking at word problems. The question for today is, how can I apply my solving of linear equations to real-world problems? So as I said before, what we're going to be looking at is we're going to be looking at applications of linear equations. In other words, we're going to be looking at solving word problems. And we're going to be looking at specific types of word problems. The specific types of word problems that we're going to be talking about today are mixture problems. And what do I mean by mixture problem? A mixture problem is any problem in which two items are being mixed or put together. For example, you may be talking about two separate bank accounts. You're depositing a large chunk of money into two separate bank accounts. You want to know together, once the bank accounts are mixed, how much interest you'll make. Let's say you're a chemist and you're taking a certain high acid solution and mixing it with a low acid solution, and you want to know what the new solution is going to look like. You're mixing the high and the low acid solutions. You're mixing denominations of money. I've got nickels and dimes. I'm going to mix them together. How many do I have together? So anytime that you're putting together two separate entities, it's called a mixture problem. Now, when we use mixture problems, we use this chart right here. And let me explain what this chart is. And I'm going to start with the rows. The very first row is your formulas. This is your formula. And the formula is this. The first is your how much, or your quantity. This bar represents multiplication or times. The second row is your rate. This will almost always be a percentage. Almost always. This bar represents the equal sign, and this particular column represents your how much times your rate. This second row and this third row are going to represent the two separate quantities you've got. So this is the first item that you're mixing, this is the second item that you're mixing. So for example, the first bank account we look at, how much is put in at what rate? The second bank account we look at, how much is put in at what rate? Does that make sense? Once again, in these columns, this represents times, this represents equals, this represents times, and this represents equals. Now this pink bar down here represents kind of the end-all be-all, where we really want to be. I really want an interest rate of da-da-da-da-da. I really want an acid solution at 13%. I really want to earn this much. And for this chart, what's really cool about this chart is as you go down, you add. So anytime you go down in this chart, you add. And I'm going to represent what that looks like in just a minute. All right, let's look at an actual problem. So we've got Mark here, and Mark has won some money in the lottery. So it says after winning state lottery, Mark has $40,000 to invest. So he's got $40,000 to put in an account. He's going to put part of the money in an account paying 4%. He's going to put the rest of the money, or the remainder, into stocks paying 6%. So what we're doing is we're taking two different accounts. This one only pays 4%, this one pays 6%, and we're going to mix them because he wants a total interest rate of $2,040. He wants a total interest rate of $2,040. How much should he invest at each rate? Well, let's look at our chart. Remember, this column is our how much column. This column is our rate, or our percentage, and we've got our times and our equals. We're not worrying about the plus, we're not worrying about any of that yet. This row right here represents my first account. So let's look at my first account. All it says up here is he's going to put part of the money in an account paying 4%. He's going to put some of his money in an account paying 4%. Okay, well, I know that the rate is 4%. Now, of course, we're going to put that in as a decimal. We never put it in as a percent. So the rate is 0.04. But I don't know how much. It says part of the money. He will put part of the money. Well, since I don't know how much that is, I'm going to represent that with an X. So if you look, what I've got is part of his money at 4%. And of course, if we multiply that over, we've got 0.04x. Now let's look at our second account. Our second account is right here. Let's look at our second account. He's going to put the remainder of the money, so $40,000, take away whatever he put into this account, what's left over, in a 6% account. So down here for my 6% account, how much is he putting in? I don't know. Let's look again. The remainder of the money. He had $40,000 total, but he put some of it up here. So out of the $40,000 that he had, he minused or took away this amount because he put it in the 4%. So this represents some of the money at 4%. This represents the rest at 6%. And once again, if we multiply that across, we get 0.06 times 40,000 minus X. I ran off my box there. Now remember when I told you that this pink bar represents kind of the end-all be-all, what we want to get, the ultimate. Well, it says right here that he wants interest of $2,040. This is what he wants. This is his end-all be-all. This is what he wants to get out of this. Now he wants $2,040, but it doesn't matter what interest rate that's at. He's going to get it from these guys. It doesn't matter how much. He's going to get that from these guys. So in this particular case, we're not going to use these bottom two boxes. Now, remember when I told you earlier when we go down, we add? What we have is 0.04x plus 0.06 times this quantity equals $2,040. And what we've done is we've created the equation that we need to solve right here. 0.04x plus 0.06 times 40,000 minus x equals $2,040. So we've created the equation we want to solve straight here in our right column. I'm distributing my 0.06 in. I'm going to put my like terms together, and since I'm not going over the equal sign, I am not going to use my inverse property. It's just negative 0.02x. Now I'm going to put my numbers together, and since I am going over the equal sign, I'm going to use my inverse property here. And once again, I'm going to use my inverse property because I'm going over the equal sign. And it looks like x equals $18,000. Now, that's only part of my answer. Let's look back at what it asked us to solve for. How much should he invest at each rate to get $2,040? Well, if x is $18,000, that's what he invested in the 4% account. If x is $18,000, that's how much he invested in the 4% account. How much did he invest in the other account? Well, what we need to do is we need to take that $18,000 and we need to plug it in. What's $40,000? Take away $18,000. He invested $22,000 at the 6% rate. So what your answer is going to look like is this. At 6%, he invested $22,000. At 4%, he invested $18,000. Now, I don't want you to panic about these word problems. We're going to be working a lot in class on these, and we're going to constantly review them throughout the chapter.